Hello and welcome to Beamer Folk. This is part 2 of my magic gesture controlled DDS, that is direct digital synthesis signal generator. If you haven't done so already, I urge you to have a look at part 1, and I'll put a link in this video to that part 1, and it should be up there, and I'll include the address in the description below. Second to that, it's probably worth looking at as a matter of interest. The PC board, which is a strip board PC board inside here, it was partly discussed in my video. I think it was titled Prototype to Printed Circuit Board via a Gainful Strip Board. The density, and that video would be here. And again, I'll include a link in the description to that. The strip board here actually has quite a density of components, and you can achieve that on a strip board. But coming back to this, what you just heard, and I've switched off the audio output for the sake of convenience. And what I'll do now is just describe the features. In part 1, I more or less outlined the features, but as this has developed, I've included a couple of other additional features. So, first of all, we've got this, on this DSO, we've got a sine wave here, and it's running at 1 kilohertz. Well, as a signal generator, and incidentally I am slightly confused, and I don't know whether anybody can help me here, but I'm slightly confused over the word signal generator. It seems as though today it's called a function generator, and then of course we have an arbitrary wave generator. Well, I'll give you my definition. I'm not sure that this is the official definition, but to my mind, a signal generator has the basic features, that is, of a sine wave, triangular wave and square wave. A function generator expands on those 3 basic shapes. So signal generator to me has 3 shapes. A function generator has more than 3 shapes. And an arbitrary wave generator where you can more or less construct any shape you wish by way of a signal. But if somebody has a more defined and accurate description, please let us know in the comments. Right, going back to this signal generator, it's conventional in a way. I'm running this now as a sine wave, and as you can see, it has 2 controls. The controls are set very high on this enclosure, and incidentally the enclosure here is an upcycled cotton bud box, as you could probably see in the thumbnail picture. But going back to this, you have a a simple level control, which I'm trying to avoid the optic sensor. You have a basic level control, and you can see the DSO is going up. The DSO gives a very noisy representation of this signal. That is an attribute, an artifact of this cheap scope. And you can see that I've got a conventional level control there. And if I get this down to as much as 0 as this will show, and then adjust the, try and not get my hand in the camera view, as you can see now, you've got a shift in offset, and I'll bring it to more or less back to 0. There we go. And if I adjust this back up, you can see the 1 kilohertz sine wave. Well, moving on, I'll just go round the bits on this enclosure. You've got naturally an output phono socket. It's not soldered wired in yet because I'm in the process of dismantling and reassembling this enclosure as I develop the prototype. So I've got basically 2 wires coming out, and my connections to the scope and amplifier coming crop clipped onto those wires. On the front you have presets, and that preset switch is a 3-position switch. You could have a switch with more positions on it or less, depends on how you feel. I had in stock a 3-position switch, and what this does is when you power up the signal generator, dependent on what position this switch is in, will produce the reference signal on switch on. So I've got this set to 1 kilohertz, 10 kilohertz and 100 kilohertz. If I set it to 10 kilohertz, when I switch the signal generator on, immediately it will display a 10 kilohertz signal, but I've got it far left, so that's 1 kilohertz, and that's the reason why you're seeing 1 kilohertz on the screen. It is possible, and I'll show you that in a second, to actually, whilst you're using this, reset back to that reference level. So if you're, say, at 5 kilohertz and you want a quick and immediate way of going back to 1 kilohertz, all we have to do is operate the reset and it will do that. So we've got the controls out of the way, we've got the front panel out of the way, we've got the output connection. You've got a USB connection going into the Arduino Nano, which is in here, and I've got a small drill hole over the reset button, which I haven't used so far, but if you needed to use it, it is there. On the left hand side, and I'm tilting this carefully, I'm trying not to get reflections back into the camera and not disconnect my wires, but you've got here a multifunction push button switch. That's why my thumb's here, and as you can see ergonomically, this enclosure fits around my hand, my left hand, with my thumb on that button. Anything else to be said? Well, you've got here, of course, the optical sensor, and that gives me the gesture control ability of this signal generator. I tried to operate this optical sensor, which is a APDS 9960. I've tried to operate this behind plastic, in other words not cutting a square hole above it, but it doesn't function. It does actually have to have clear air between your gestures and the sensor, and as you can see, which I cannot see, you can see that there is a mauve LED light showing through the camera. The camera shows up the infrared image, whereas my eyes do not. Now then, let me just go through what I did when we had the audio amplifier on, and I won't switch that back on again. for purposes of clarity. So if I go swipe right, you shall see one of the 4 LEDs come on up here. They're in a compass configuration, or left, right, up, down. And if I go now, if I swipe right, you will see the blue indicator, blue for blue shift, the frequency is rising, wavelength getting shorter. And if you look on the DSO, you'll see that the frequency is now increasing. If I push the button, bang, it stops at that frequency. The frequency changing on this signal generator chip, which is the AD9833, linearly progresses. That is to say, it doesn't switch from frequency to frequency in increments. It actually moves linearly, which is a very nice feature, and it does open up the possibility of doing an audio sweep test. Now then, if I want to reset back to my 1 kilohertz, I push the multifunction button here and then swipe up, and you see we're back to 1 kilohertz. If I remove my finger from the button, let me get the button back in shot. If I remove I'm indicating I'm nowhere near the button, and swipe downwards, you see the green for grass, earth, downwards. You see that the signal has changed to a triangular wave. So that's the 2 wave shapes. So how do I generate the 3rd wave shape? Well, what I do is put my thumb on the multifunction button there and swipe down again. Green indicator coming up, and you can see what's happened. You've gone to a square wave, and if I want to drop that square wave down, indicating the left hand LED on the compass display, no, it didn't take, there we go. You see the red indicator coming up, indicating red shift or a longer wavelength, and there we are. And then I push the multifunction button to stop lowering frequency. Now let me get back to 1 kilohertz, push my thumb on the multifunction switch and swipe upwards, and there we are, we're back to 1 kilohertz triangular wave. Get back to sine wave, thumb off the button, back to sine wave. That's more or less how this is controlled. Is there anything else? There are a couple of points that I wish to add, and that is that the software for this I consider not complete. Will it ever be complete? Probably not. Nothing by way of software is ever complete, is it? Right, the first thing is that for the sake of functionality as a signal generator, of course, if you have a very low frequency shift, it'll take you a fortnight to get from, say, 1 kilohertz to 20 kilohertz. So what I did within the software, and I'll show the software, probably it's not complete yet, so it might end up in part 3. What I did was to dynamically change the speed in which change occurs in just 2 steps. Basically, it could be more steps, but at the moment it's just in 2 steps. And that is that after 10 seconds of slowly shifting either up or down, it suddenly shifts gear, changes gear into a fast speed change. So it might take you 10 seconds to get from 1 kilohertz to, say, 2 kilohertz, but it'll take you 3 seconds, 5 seconds to shift from 2 kilohertz through to, say, 10 kilohertz. To make this more usable as a signal generator. So I just kind of show that. We're in sine wave at the moment, so if I shift right, so we're going to increase the frequency, you'll see that the blue light has come on to indicate that I'm shifting shifting to a higher frequency, and you can see the scope now moving, and there you go. It stepped to a very fast change after about 10 seconds. In fact, that didn't seem 10 seconds. I may have adjusted it to 5, but that is the principle that I've developed in this, that if you drop frequency, it does exactly the same in reverse. So let me just carry on increasing the frequency here. The DSO will go peculiar, but then it's always peculiar. Let's just yeah, here we go. Right, it's going there. Right, now if I reverse this and I want to go to a lower frequency, all I have to do is swipe left, which is the red indicator, and the frequency should be dropping. Of course you can't really see that, but in a second, well, 5 seconds, 10 seconds, you'll see it step. There you are, it stepped, and we're now dropping in frequency very quickly. And if I push the multifunction push button, it will stop at the frequency at that moment. Now that's the first thing. The second thing is, if you've watched part 1, I mentioned there that the square wave, and let me go into a square wave, so I need to have my thumb on the push button, and there we go, we got a square wave, and I drop its frequency so we can get a better image of it. The square wave, if you remember, this chip, the what is it, the gone too low, haven't I? Let's increase that. I'm fighting this DSO all the time. Let's increase this to so that we can actually see a nice square wave. There you are, that'll do. Right, what is the module? The module is a AD9833. Well, that if you've watched part 1, I mentioned there that this particular module, when it operates a square wave, it operates it at 10 times the amplitude of the triangular wave and the sine wave. So in a sense, that square wave is a little impractical to, you know, when you want a square wave, you've got to adjust the level again. So what I did, I included an automatic attenuator which switches in as soon as you select a square wave option, and I've adjusted the amplitude of that attenuator so that it matches more or less you know, within a certain precision, the amplitude of the sine wave and triangular wave. That's the two things that I failed to mention. The other point is the whole of this signal generator on a 5-volt supply only consumes 70 milliamps at 5 volts. And I'm running this from a power bank, and I've been running it for the last 2 hours, and the power bank hasn't dropped. So I could at some stage include a battery pack within the enclosure, but it suits me to have an external battery pack that will last hours rather than something that will last just 20 minutes. But for the purpose of portability, it might be wise to include a battery pack. The output level of this signal generator, it's a 47 ohm output impedance. I stuck a 47 ohm resistor, although the op-amp, which incidentally is not an ideal op-amp, as I mentioned in part 1, this op-amp shuts its frequency down, well, starts to close down at 200 kilohertz, and it only goes up to 450 kilohertz, which actually isn't bad. Whereas the signal generator module, the 9833, actually goes up to allegedly beyond 1 megahertz, but its wave shapes start to deteriorate badly. I don't think you would ever really want to get beyond 1 megahertz. But I have actually now got, I've ordered 2 op amps which I hope will get me up to certainly a higher frequency that I've achieved at the moment, which at its -3 dB point is 450 kilohertz. But to save the output of the op amp, even though it's a low output impedance, and I could have connected that directly to the phono socket, I put a 47 ohm resistor in series just to protect the op amp somewhat from any unusual loads or short circuits. The op amp supply, which is a plus or minus 9 volt supply, is produced by a little generator in the back there, and that seems to be working quite well. But what I need to do is to change this op amp to a slightly better op amp, and I've made this strip board in a particular way where I don't know whether you can see this through, but I've got actually a daughter board made on the side of the rest of the strip board, so that I can actually change that to a better output configuration. This is Beamer signing out for now.